All right, we are looking at day 4 here on solving systems by elimination. So we're still working on elimination, but I do have a typo here. This should say part 2. We looked at part 1 in the day 3 notes. Okay, so what I want to do here at the beginning, I don't necessarily want you to write anything down. I just want you to listen for a moment. So what we talked about the other day was we're trying to get things in columns. Okay, so we're trying to get the x's lined up in columns. Oops, let me get a highlighter here. We're trying to get the y's lined up in columns because we want them to add to 0. So if I look at the way they are situated, this adds up to 9x and this adds up to 6y. So that doesn't help me do anything. I need either the x's or the y's to add up to 0. So here's what I want you to think about. Okay, let's look at, change this color here. Let's look at the x's. If I wanted those to add up to 0, I would want one of them to be a positive value and one to be that opposite number, like a negative value. So if you look at this, I could make 3 turn into a 6 by multiplying by a number. But I really want it to be a negative 6. So again, don't write anything down, I just want you to listen. So what I could do is multiply through by whatever number makes that happen. And that number would be a negative 2. So if I went ahead and rewrote it, I would have a negative 6x, but you have to distribute it all the way across. Negative 2 times 5 is a negative 10y, and then negative 2 times negative 9 is 18. And then this one I don't have to modify, so I'm just going to recopy it underneath. So now look at the x's. See how they add up to 0? Oops. So if I go through this, these are going to go away, and then I could solve. Okay. Or, back up here. What if I wanted to look at the y's? So right now it says 5 and 1. Let's make the bottom one be a number so that when it adds to 5, I get 0. So you want the opposite of 5, which is negative 5. So then your next question is, what should I multiply through by to make this 1 say negative 5? Well, I should multiply through by negative 5. So remember, though, you have to distribute that in. So over to the side, I can recopy equation 1. Now multiply in on equation 2. That's going to say negative 30x minus 5y, and then negative 5 times 9 is negative 45. And then when I go to add, do you see how these add up to 0? Okay, so that is what we're trying to do here. If the x's or y's don't add up to 0, you have to force that to happen. And the way we do that is we multiply through by a value to make the variables add to 0. Okay, so I would like you to pause. Let's go ahead and just keep working on this problem. So go ahead and pause this video, excuse me, and copy down what I have. And then when you are done, come back to the video, hit play, and we'll just keep working this problem out. Okay, so the y's add up to 0, and so when we add the x's, 3 plus negative 30 is negative 27. Negative 9 plus negative 45 is negative 54. So then I just solve. Divide by negative 27, divide by negative 27. And when I do that, I get x equals positive 2. Okay, so remember, I am still making an ordered pair as my solution. So I have 2 in the x-coordinate. Now let's plug in 2. So I'm going to go back to either equation, either the first one or the second one before I changed anything, and plug that value in. So I'm actually going to choose the second equation. I'm going to choose 6x plus y equals 9. Okay, now let's take our negative 2 here and plug it in for x. So I'm going to do 6 times 2. I think I said negative 2. Take our positive 2 and plug it in. Plus y equals 9. And then let's just keep going. 6 times 2 is 12. Take away 12 from both sides. Okay, and then we arrive at our answer for y. So 9 minus 12 is negative 3. So come on over here, let's add in our negative 3. And we now have our final answer. Now remember, we can plug these numbers in, 2 and negative 3, into each equation for x and y and make sure that it ends up equaling what the equations are equal to. Okay, so bottom line here, make sure the x's and y's are lined up in columns, and so are the equal sign and then the number without variable. What do you need to multiply through by to force the adding to become 0 on x or y? All right, I'm going to actually have you pause. I want you to try number 2. So get as far as you can or get finished with it and come on back and we will go through it. Okay, couple of comments here before I start actually working this out. Let's just think through our options. I have 7 and 3. So I can't just multiply, well, I could multiply 3 by a number to equal 7. I could multiply by 2.5. No, that wouldn't even give me 7. I'd have to multiply by a fraction. So let's skip that. What that means is I would have to change both 7 and 3 into different numbers, which would be a little bit more complicated. So if I wanted to do that, I could make 7, if I do 7 times 3, I get 21. So if I did that, I could make one of them say 21 and one say negative 21. So if I wanted to do that, I would have to multiply maybe the top one by negative 3 and the bottom one by 7. And then that would give me negative 21x and positive 21x. I could do that. Or if you look at the y's, 2 and 8, negative 2 and 8. So I could actually just multiply negative 2 by a number and turn it into an 8. Now, it's already positive and negative, which is good. So what I probably will do is start with the y's because I only have to change one of the equations. All right, so let's go in that pathway. So if I want to change 2 into 8, what should I multiply by? Well, I want to multiply by 4. Now, do I want to multiply by positive or negative 4? Well, when I check that, 4 times negative 2, I get negative 8, which is what I want. So that's what I'm going to stick with. So recopy the top equation because you are not changing it. And then modify the bottom equation by distributing 4 to all 3 pieces. So that would be 12x. 4 times negative 2 is negative 8, which is what I wanted. See the positive and negative 8. 4 times negative 1 is negative 4. Okay, so let's add. Okay, here's my canceling, which is what I want. So I went ahead and did that. 7 plus 12 is 19. And then don't forget to add over here. 23 plus negative 4 is also 19. So solve for x, divide by 19 on both sides. And I get 19 divided by 19 is 1. So I get x equals 1. All right, so I do like to start my ordered pair once I get one of the values. So I got x, so that goes in the first part. All right, let's take that and go either to equation 1 or equation 2. I'll just maybe stick with the first equation. So let's plug 1 in for x. So I'm going to do 7 times, plug in what we got for x. We got 1. And then let's write the rest of the equation out. Plus 8y equals 23. And then now we just solve. So that would be 7 plus 8y equals 23. Next step would be to take away 7 from both sides. All my color switching here. Cancels out. We have 8y equals. So 23 minus 7 is 16. And then now divide by 8, and we get y equals 2. All right, plug in your 2, and you are good to go. We have our 1, 2. Okay, So there's a couple ways to start this. You just have to think ahead, what do I want to disappear? Okay, let's look at the next one. All right, example 3. Okay, think through your options. X's. So one says 2, one says 4. I could make the top one say -4 if I multiplied by a -2. Okay, I could do that. Let's say I wanted to do Y's. 3 and 6. I could turn 3 into 6, but I wanted to say -6, so I should multiply by a -2 again. Okay, so let's do that. Let's see what we get. So I'm going to just decide, I'm just going to take the top equation and multiply by a -2. All right, distribute that to all 3 pieces. Multiply it in. -4x minus 6y is -10. You're not changing the bottom one, copy it underneath. 4x plus 6y equals 6. All right, we are ready to add columns. -4 plus 4 is 0. Look at the y's. -6 plus 6 is also 0. So I need to write a number down here. I'm getting 0 plus 0, so I just have 0. -10 plus 6 is -4. Okay, variables dropped away, so we're not going to get an ordered pair. This is a false statement. 0 is not equal to -4. So therefore, this is a no solution. There's no number that will work to make this system true. Okay, try number 4. Go ahead and pause here and work through number 4 and then come back to the video. We will check it. All right, I am going to make the top equation, I'm going to work with x's. And so I want to make that top x say -3, so when it adds to the bottom 3, it will be 0. So when I distribute in -3x minus 6y equals -15, bring the bottom one over, 3x plus 6y equals 15. All right, let's go ahead and add. -3 plus 3 is 0. -6 plus 6 is 0. -15 plus 15 is also 0. So I have 0 equals 0. That's true. 0 does equal 0. So if that is a true statement, that means every number is a solution. Whoops. So this is our infinitely many solutions. Every number in the world will work. Infinitely many solutions or many solutions, you know, either way that'll work. Okay, let's take a look at number 5. Actually, I would like you guys to do number 5. Looks like my spacing is off, but please pause and then go ahead and do number 5 and then come back to the video. Okay, if you got this correct, let me go ahead and put the correct ordered pair up here. It should be 2, 1. Okay, but let me work through this one if you didn't get that. So I'm going to, even though my columns are a little off, I actually am going to need to change both equations. So I'm going to work with 5 and 2. I can make 5 and 2 turn into a 10, but I want one to say +10 and one to say -10. So let's make the top equation say -10 when I'm done multiplying. So that means I got to multiply by -2. If I want to make the bottom one say +10, I'm going to multiply through by just a +5. Okay, so let's distribute and bring that over. So I'm going to have -10x minus 6y equals -26. And then along the bottom, I'm going to have +10x minus 25y minus 5. All right, let's add. That's my canceling. That's what I wanted to happen. So negative 6 minus 25 is going to be negative 31. Negative 31y. Whoops. Equals negative 26 minus 5. Oh, that's negative 31 again. Okay, so when I solve for y, I get, oh gosh, too many negatives over there. Okay, divide by negative 31, divide by negative 31. So that gives me positive 1. Okay, so there's my 1. And then when I plug that back in, I should get 2. So I always go back to the original equations. So if I take the top equation, oops, gosh, 5x plus 3 times the 1 I calculated is 13. So that would be 5x plus 3 equals 13. So move the 3 over, take that away from both sides. So 5x equals 13 minus 3 is 10, and then divide off your 5. And so there is your 2. Okay, so sometimes you must change both equations. Sometimes you can only change one. Okay, I am going to stop this video here, and I'm going to come back with a second video to do those 2 word problems.